Prova, prova, prova. 1, 2, 3, sassa. Ma vediamo come reagisce sta cosa. 11 la madonna. Ok. Si sente qua? Prova, prova, prova. Encoding overload. Consider turning down video settings using a faster. Si sente qua? Sì. Okay, let's do this. So, now we're back again to a Mac OS, well, iOS Swift programming stream. So the thing is, now we're gonna be starting the chapter 2, which is focused on drawing and animation, as far as the documentation says. Here it says, drawing paths and shapes. Users receive a badge whenever they visit a landmark in their list. Of course, for a user to receive a badge, you will need to create one. This tutorial takes you through the process of creating a badge by combining paths and shapes, which you then overlay with another shape that represents the location. If you want to create multiple badges for different kinds of landmarks, try experimenting with the overlaid symbol, varying the amount of repetition or changing the various angles and scales. Follow the steps to build this project or download the finished project. So, I downloaded the files in this case, so I got all the... Let me see. Do I have all the files that I need? And for the time being, I might as well follow. So let's take a look at this. Handling user input, we did that yesterday. And building lists as well. So now we're doing drawing paths and shapes. I'm just going to prepare this, so at least we have it. Do we have any resources in here? Apparently we will use some. But let's start along with the different chapters here and see what this has to offer. So section 1, creating create drawing data for a badge view. To create the badge, you'll start by defining data that you can use to draw a hexagon shape for the badge's background. In the Views group, selected in the navigation pane, choose File, New File, select Swift File from the iOS template sheet and click Next. Okay. And the landmark is broken for whatever reason. Alright, interesting. So, we are doing this in the... what again? Views. So, come on. Okay, hold on a second. Don't break up me, please. File. New, yes. File from template. We're gonna be calling this hexagon parameters .swift. Okay, so this is a normal Swift file, not a SwiftUI. So we're going to be building, you will use this structure to define a shape of an hexagon. So hexagon parameters. Alright. We can remove these comments. There we go. That is done. Inside the file, create a structure called hexagon parameters. Okay. So, struct hexagon parameters. That is if the system decides to follow along with me. Define a segment structure. Oh, so a structure within a structure, nice. A segment to hold the 3 points that represent one side of the hexagon. Import core graphics so you can use a CG point. Each side, okay, each side starts where the previous ends, moves in a straight line to the first point, and then moves over a Bezier curve at the corner to the second point. The third point controls the shape of the curve. Okay, so we got 3 CG points to deal with here. Okay, import core graphics. Cool. So now we just define another struct and we call it a segment. We said that we need 3 points. So the first one we said that it's going to be the line CG point, not pointy. Let the curve CG point, no CG point. And another control CG point. Why is the system so slow today? What is going on? Jesus. This is taking up a lot of resources for whatever reason. And I think it might be the enhanced streaming thing that I activated. Not sure if it's going to improve the quality of the stream, but it's nice to have. Problem is that it seems like it's chugging up a good bunch of resources. Create an array to hold the segments. Okay, that's fine. Oh god, I can already see that this code is gonna look terrible, but since we have to do it, let's do this. Okay. So we're going to create this for whatever reason static without any explanation. Oh, fair enough. There we go. And we're going to be creating how many segments? Add data for the 6 segments for the hexagon. 1 for each side of the hexagon. Yeah. The values are stored as a fraction of a unit square, having its origin in the upper left with positive x to the right and positive y down. Later you'll use these fractions to find the actual points of a hexagon with a given size. Okay, fair enough. Sure. So let's build all of these segments. This is quite the repetitive code, so I'm just going to write it once and then I'm just going to copy paste it every single time, because otherwise I'm never getting out of this. CG point. Can I make all of these CG point zeros? That would have been more interesting. So I'm going to make it 0.1 and 0.1 for the time being and copy paste this over and over again. Tac. So this is not line, this is curve, and this is control. Yeah, let's not forget the commas though. 1 and 2, there we go. And I can just copy this. Maybe along with a comma would be better. So I just copy this, paste it 5 more times. God, this looks ugly. Okay. And let's take the values that they tell us to give it. So 0645 645 with 550 here. Okay. So it's a 0.0. Okay, cool. 500. This must be the top one, I'm assuming. Since oh no, it's x0. I need to understand this. Because the curve is like this theoretically. 2, 3, 25. Okay, yeah. 050. 95. Oh no. 4, 6, 5, 95, 1, 0, 1, 0, and I'm gonna do the Y's later. 1, 0, 95, 1, and now let's do the Y's, otherwise we're gonna forget. So for the Y's we got 7, 8, and 75. I'm curious to see how this is gonna look afterwards. 95, 95, 1, 8, 7, 75, and 30, 20, 25. 30, 20, 25. And I think we are done with this segment, so that's good. And step 7, add an adjustment value that lets you tune the shape of the hexagon. Oh, so we got the top and the bottom, that's fine. So what's the point of the adjustment? Okay, I think we'll figure it out later. And again, still static without explanation, but fine. Adjustment TG float 0.085. And we're taking the 2 segments and adjusting its Y value. Okay. Adjustment. There we go. So we can just apply this everywhere to the Y values, and then the others are just negative so that you can rotate it, I'm guessing. Oh, it's minus. There we go. And the other 2, this one. Okay, cool. So we added the adjustment, we added the different segments that make up the hexagon. That much is fine. Now, section 2. Draw the badge background use the graphics API in SwiftUI to draw a custom badge shape. Oh, okay, I see. To create a new file with SwiftUI view from it. Okay, create a new file with file, new file. This type, selecting SwiftUI view from iOS template sheet. Click next, and then name the badge background. Okay, so it becomes badge background. File, new, file from template. This is SwiftUI, and we're going to be naming this badge background. Okay, cool. So we got the preview and we got the bit of code. So in badge background, add a path shape to the badge and apply the fill modifier to turn the shape into a view. You use paths to combine lines and curves and other drawing primitives to form a more complex shape, like the badge's hexagonal background. Okay, interesting. So this one is a path with a code block. It takes a path in. I'm pretty sure that's going to be the hexagon at some point. And this, we're going to be filling it with just pure black. So how is this going to look? So in this case, it's... okay, there's still nothing. Add a starting point to the path, assuming a container with size 100 by 100. The move to method moves the drawing cursor within the bounds of a shape, as though an imaginary pen or pencil is hovering over the area, waiting to start drawing. Okay. Oh, so it's... come on. So it's almost like I can just decide live what I want this to look like. So, bar width. Let's do this the way the tutorial tells us to. Float 100.0, bar height is equal width, so it's 100 by 100. Path dot move to CG point, and in this case it's x width times 95, 0.95. So it's 95% of it. If only I can put it. There we go. And y as width, no, height, which is the same as width. Okay, fine. Times 0.20. So 20% of 95% of the width, 20% of the height. Should make a little rectangle, I think. Question mark. What am I missing? Draw the lines for each point of the shape data to create a rough hexagonal shape. The add line to method takes a single point and draws it. Successive calls to add line to begin a line at the previous point and continue to the new point. Okay, interesting. So I can make a hexagon like this. What is this? Oh, that's fun. So we're still in the path part, but this is not... okay. Hexagon parameters dot segments dot for each segment in. I need to start writing my code more like this. This is a little more readable to a certain extent. Path dot add line to CG point, yeah, with x as the width times segment dot line dot y dot x, and the y as the height times segment dot line dot y. So now it's supposed to be drawing the hexagon in theory, if it doesn't crash on me. God damn it. Will you please just show me what I'm coding. Ah, there we go. Thank you. That looks broken. That is not what I was expecting. So hold on. Why is this? Because I can understand that this is the 100 times 100 and it's showing everything in the whatever value this is. So what gives? Oh, don't worry if your hexagon looks a little unusual. That's because you're ignoring the curve part of the segment and the shape's corner. You will account for that next. Use the add quad curve to control, so it has two parameters, method to draw the Bezier curves for the badge's corner. Okay, not a problem, sure. So hold on. Let's clean this up a bit. Let's clean this up because this is becoming unreadable now. So we got a CG point here, that's fine. We got the X and Y values. No doubt there. So this is the closing parentheses for the CG point. This is the closing parentheses for the line. And that's fine. Let's just move this to the line as well. We got the X. We got the Y. And there we go. So now it's getting a little more readable. I still like this at the next line though. It makes me feel like I can understand what it is that this is taking into account since it's the first parameter. Now we need to add what? The adjustment apparently. So to the 020 here, we need to add the hexagon parameters adjustment. That's one. And second, we need to add the curve to the same path actually. Okay. So to this path, we need to add the add quad curve, and it's taking these two parameters, 2 CG points. Come back. There we go. So it's taking these 2 CG points into account. That's fine. That's okay. Now let's declare these 2 CG points as what? X and Y again. There we go. With this being the width segment dot curve. There we go. Yes. Dot X. And the this one being a CG float. It's not a CG float. Oh yeah. No. Okay, hold on. Yeah, this is a CG float. Height times segment dot curve dot y. Yeah. So we got the x and y for the 2 parameter. Okay. And now we just need the CG point for the control, which we already declared as well. Here. So the 2 point is done. There we go. And now we add the other one. Come on, there's supposed to be an x and y here as well. X width times segment dot control dot x and y as the height dot times segment dot control dot y. Good. It still looks very ugly and very broken though. What is this? This looks worse now. It doesn't. Okay, we got the curvature, but it still looks like nothing. Is this supposed to be looking like this? What does the tutorial say? Not really. It's supposed to be looking like a hexagon to them. So what happened? What did I do wrong? What am I missing? CG float 100 width. Yes. Width times 0. Oh wait. This needs to be this needs to be a single value, not just something added to it. This is a single value. Will it change anything? It changed nothing. What else did I miss? Segment for your CG point width line X. So it's XY, 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 just for the sake of it, yes. Height. Segment line. Segment curve. Segment control. What am I missing? I'm confused now. I am very much confused. Times 0.95 and with the adjustment. That's fine. Am I missing something? Okay. Hold on. Okay, I'm gonna... It's supposed to be looking like what exactly? Because I'm doing this. And the first preview here, what does it look like for them? Like a broken hexagon. Mine doesn't even look like a hexagon. It looks like whatever the hell that is. So, what am I missing? What did I miss? Hold on, let me check the values of this again and compare it with the original code. 645 05 oh 005 005 okay 005 00 okay I'm gonna 040 050 yeah 005 020 030 025 and this is 005 as well. Okay, that makes more sense. 000500 along with 70 and 80. Now it feels more legit. There we go, 100, that's fine. Are we sure that these are correct as well? 80, 70, 75 with 1, 1, 1, that's fine. So this is good, and this is supposed to be 30, 20, 25. So if these modifications are applied, now it should look something a little more logical. Let's see. Was never mutated. Ah, there we go. Yes. Now it makes more sense. Now it makes a lot more sense. Okay, good. Because that made absolutely no sense. So, wrap the path in a geometry reader so the badge can use the size of its containing view, which defines the size instead of hard coding the value 100. That's better. That I love so much. When he readapts to the screen, that is so much better. Only one hiccup with this. What am I doing? Wrap the path in a geometry reader. Oh, okay. Geometry reader. Okay, so that much is fine. I am putting all of you inside this geometry right here. Good. And we are doing what? Okay, we're adapting the width to the size of the screen. Nice. Because this should have been a 100 by 100, and now it's going to become a geometry. Oh, wait. Got to declare this thing. Geometry n as the parameter for everything here. Geometry dot size dot width. What is this? Oh Lord. Comma geometry dot size dot height. Okay, hold on. What is this? This doesn't make it. How is? Yeah, exactly. It's an XY thing. Why are we converting this into a CG float? Oh, because we're taking the smaller value. Okay, no. We're taking the smaller. Okay, that's why. We're taking the smaller value of the two, whether it's flipped or it's up. Okay, that makes more sense. So in this case, we're taking them. That's why they put the minimum in there. Using the smallest of the geometry's 2 dimensions, preserve the aspect ratio of the badge when it's containing view isn't square. Yeah, that makes sense. At least it readapts the screen, like the size, based on whether or not you have it horizontal, because the height becomes the smaller value, or the width, because the width becomes the smaller value in size. So yeah, that makes sense based on the geometry of the item, unless it's a block. In that case, it doesn't matter, it's the same value, but yeah, since we want to keep it a square, it's taking the smallest value available within the screen size itself. And okay, this makes perfect sense. That's actually pretty smart. That's a smart way to do it. I like this. I think I'm going to be applying this to my future codes as well, because it makes perfect sense depending on the person's the device's orientation. Scale the x-axis using x scale and then add x offset to recenter the shape within its geometry. That's also nice. So what are we doing here? We're declaring x scale and x offset. Oh, it's got some very weird values. Okay, let's try and understand this later on. I can let the height stays the same, because let. There we go. This is the only one that doesn't change apparently. Let x scale equals cg float, which equals to 0.832. I don't know why this is a value like this, but sure. X offset equals width times another inner value, 1.0 minus x scale. Okay, I see the logic. I can understand it. Still weird. Width is equal to times equal to x scale. What do you want? Oh, wait, this is wrong. There we go. It's a CG float type. So this much is fine, and then what? We're adapting the size based with the value of the offset. X offset, that is fine. Same thing for the line, the curve, and the control. Okay, so all of these are just readapting themselves. Offset. Yeah. Good. And good. And with this it should... okay. Okay, good. What else? Replace the solid black background with a gradient to match the design. I mean, sure. I like the fact that we're just adding colors into this. It's perfectly fine, so it's not just straight up pure black. Linear gradient. So, what's the values that we're adding here? Gradient. We got 3 parameters into this. Colors. And then what is this? Color, start point, and end point. Okay. So we need a list of start and end point. Yeah, okay. So this is a list of self dot gradient start. And then we declare the start point and end point. Okay, fair enough. Can I already do this? I sort of can't. Okay, I tried. Go back. Self dot gradient dot start and self dot gradient end. Good. And now start point is a unit point. Yes, that is true. x and y values of 0.5 and 0 apparently, okay. And the endpoint of a unit point, yes, of x and y values of 0.5 and 0.6. I have no idea why these are the values. Like this is the problem. It's like I am understanding why we're doing this, like with the gradient, just for the coloring. Oh, static again with the statics. That gradient start. So this is the first color with RGB, I think. Does it allow the yellow, cyan, and magenta as well, or is it just RGB? Red. 239.0 divided by, so with the 255, I'm just gonna copy paste this for the green and blue. Red, green, and blue. So this is blue, and the other is green. Green, good, perfect. So we got the gradient start and we got the gradient end in this case. What's the difference in colors? What are we doing? So 120, 172 for the green. 122, 120 green, 172 good, and 221 with 120. So far, so good. I'm not sure how this is going to turn out. Let's see. That is, if it decides to load for today, we might be able to make. Oh, pretty! Okay. Okay, that's nice. That looks very, very nice. I like it. Apply the aspect ratio apply the aspect ratio with the two parameters apparently. Modifier to the gradient fill, preserving a 1-to-1 aspect ratio, the badge maintaining its position at the center of the view, even if its ancestor views aren't square. Oh, okay. Where do we do this? 1 point below, 1 point above here. One content mode dot fit. And let's see how this looks. Okay, did I forget something? We're in the path, right? We're applying this to the path. We're not applying this to the geometry reader. What is this? Cannot infer contextual base. What? What? Hold on, that doesn't make any sense. Oh, I'm applying this to the wrong thing. It's not to the path. It is to the geometry. We are applying this to the geometry. We are applying this to the geometry. We're not applying this to the... Hey, come on. Is it actually still broken? Okay. Hello? This is stupid. What is going on? I'm applying this to what? The geometry, right? It's not. I'm not applying this to the body. I've already gone far enough with declaring the var geometry. Apply the aspect ratio content mode modifier to the gradient fill. This is so confusing. This is so very much confusing. Why? Scusa, 1, 2. This is so confusing. What am I missing? What am I missing here? So, okay. So hold on. Let's close this for a second. Let's try writing this again. Because clearly something is not right. So you save, you go back to the original. That's fine. Not a problem there. I'm supposed to be applying this to the what? Am I applying this to the body? No. I'm applying this to the geometry reader in this case. So what modifiers do I have? Aspect ratio. Yes. Content mode. Fit. Are we happy with this? Ah, okay. So this, okay, that's fine. Now we're good. Now we're happy. We don't need. I don't need to declare. Why is this documentation outdated? Why does it say that it has 2 parameters when it takes only 1? Okay, I might have missed something, or is there any way for me to read the documentation here about this? Like, do we have other parameters to this? So here it takes the aspect ratio, and it can be nil. Oh, okay. So in theory, the aspect ratio does take 1 parameter beforehand, which it can be nil in this case, and that's fine. But we can just go directly into the content mode. So the 1 there is perfectly correct. Then why is it giving me an error the moment that I apply it? I mean, it is 1, so it's a 1-to-1. That's fine. It's not a 3/4 or whatever. So that much is fine. But does that mean that now if I add the 1, it's going to break? Like, will it break now? Looks the same. Didn't really change much. Okay, good, I guess. Now, draw the badge symbol. The landmarks badge has a custom insignia in its center that's based on the mountain that appears in the landmarks icon. Yeah, ironically, I don't have that, but sure. The mountain symbol consists of 2 shapes, one that represents a snow cap at the peak and the other that represents vegetation along the approach. You will draw them using 2 partially triangular shapes that are set apart by a small gap. Ooh, that sounds nice. First, you'll give your app an icon to establish a look for the badge. Navigate to an empty app icon items from your project's asset catalog and then drag a single PNG file from the downloaded project's resources folder into the existing empty app icon set. Okay. And now if I go here and I go into the app icon one, it's pretty much empty. Go into the downloaded files, resources, landmark app icon 2024 by there we go. So we got the app icon here. That is good. We like it. Next, you will build the matching badge symbol. Step 2. Create a new custom view called badge symbol for the mountain shape that's stamped in a rotated pattern in the badge design. Okay, so we're creating a new view. Come here, you. File, new. So in this case, it's a SwiftUI file. Fair enough. SwiftUI, next. And we're calling this badge symbol. Okay, we can remove this. It's useless. And let's remove. Let's just leave this empty for now. What is this? Draw the top portion of the symbol using the Path API. Adjust the numeric multiplier associated with the spacing, top width, and top height constants to see how they influence the overall shape. Oh, okay. Okay. So let's start with the geometry reader. I like this geometry reader so much. This is really cool. Geometry N, and we create a new path. There we go. We keep it like this. Path N, left, width, and so we take just like before, geometry dot size dot width, comma, geometry dot size dot height. Take the smaller value of these two, that's fine. So there we go. So far so good, and now we can start drawing. So let height is equal to width equals times 0.75. We're just making this a little smaller. 0.75. Let spacing is equal to width times 0.030. That is one weird value. Let middle width times 0.5. Fair, that's half. Let top width 0.226. No, we're dealing with the height here. Height times 0.488. This, I need to change these. I'm gonna play with these values later on because they seem oddly specific. Path dot add lines. Yep. And we have a list of CG points. I actually want to go to the next line with this and close you down little by little. Go, so at least it makes it somewhat more readable. And we have a wide variety of CG points to play with here, such as, so we have 5 CG points. All of them we have X and Y values. All of them with middle as the X value for the most part. So we can already copy paste this. So let me just create these, copy and paste them, and readapt them later. Most of them we're going to be working with the middle ones. So this is the second one, top width, middle, top width, middle. So top width again, fair enough, and middle again. So it's doing something like middle, top width, middle, top width, middle. I mean, it's more like going up and down since it's the X value in this case, and then we're just going to adapt the spacing for the Y value, giving it an angle. Oh, and yeah, commas. There we go. So we got ourselves a list. How does it look like for now? Like just like this, plain and ugly. How does it look? Does it even look like anything? Oh, Is it because the y value is always the same, so it's just a straight line? Okay. Let's try this a little different then, since it's spacing nearly all the time. Top height. Okay. Top height divided by 2 plus spacing. Top height minus spacing again. And spacing. So we're just going to be moving back into the same positions. Yeah, okay. Okay, that makes sense. Makes sense, kind of weird, but it makes sense. Okay, now what? Draw the bottom portion of the symbol. Use the Move To modifier to insert a gap between multiple shapes in the same path. Oh, it's the same thing, basically. Okay. I can just copy this one, for example. So select the entire thing. Tuck. Paste. We can just add another path dot move to, and we're going to be doing another CG point with X and Y values. Y. Here we go. With the X value being middle. So yeah, we're sticking to the same distance. And top height divided by 2 plus spacing. Is that right? Nothing else? Oh, spacing times 3. Spacing times 3. There we go. I'm not gonna change its shape for now because it feels like it's I want to keep it the same shape. I just want to see it moving down before applying any modification to the other shape. Hello? What is my second triangle? What happened? And I was required for sub 7th, and I don't care about these warnings for now. Where is my other triangle? What happened to my other triangle? What is this? CG point. Okay, this is ambiguous. Oh, it's drawn on one on top of the other. That's why. Wait, what's the point of the move then? What is if I have to draw like another shape afterward? Let's try this. These values are so weird. Middle plus top width, middle. Yeah, that's fine. This looks broken beyond all recognition. Middle minus top width, spacing. Width minus spacing. Middle plus top width, middle. Weird values, but okay. Next we got, for the Y value, we got in this case, top height plus spacing. I mean, it's almost like you gotta have an idea on how you actually want this to be drawn. This is height minus spacing. The third one is height minus spacing. The other one is top height plus spacing. Oh. And the last one is top height divided by 2 plus spacing times 3. So... Oh, okay. Okay, where's the spacing? How much is spacing? Spacing is 003. Okay. Spacing is the 003. My god. Okay, now I see it. Now I see it. You really need to know this. You really need to know what you want to draw, because it doesn't really make any sense. Like, if you look at it from a first perspective, then you end up realizing how the points are moving and everything, and that's fine. But for the rest, this is extremely confusing, because everything starts like from the middle at the end. Everything goes from here, and then you kind of like start drawing all the different values of x and y together based on the position of the middle. So that's fine, because it takes basically the width, divides it in half, and then it starts drawing everything from this side and makes the same on the other side. But this is very confusing if you don't really know what it is you want to draw. Still, it looks very stylish. I gotta give it that. Now we're just going to declear the color. Again with the statics. I do not like statics when it comes down to this stuff, but we're going to follow the tutorial here, so at least we learn how these things react and work. Red, green, blue. So we keep the value here. How much do we give for the red? 79. How much for the 79? Okay. And how much for the blue? 191. Okay. 191. Good. And then we apply the filling to the path? Why not the geometry? Oh, yeah, true. There's a difference between capital self and lowercase self. Did I break it? What happened? Hey, yo, refresh. What is happening? What is this? Oh my god. I think this needs to be better addressed and better explained, because clearly I am not understanding the logic of this. So it's self for like the whole file. It takes, in this case, I wish I had better documentation than this. I mean, it's just a tutorial, so we're just learning this, but I have to read about this. Because you got the lowercase self and the uppercase self in this case, as far as I'm understanding, with a different way to which they tend to access the different attributes present within an object. And my understanding is that, so far, without reading the documentation, even though, again, I'll look into it later, you got the capital self and the lowercase self. And the capital self is like for the current object, like within the file that you're working with. And the lowercase is for the object itself that you're interacting with there within the code block. The only problem is understanding exactly how up in the hierarchy do I have to go, or can I go, for the self to actually work in this case. Like, why is the self not part of the body, but rather part of the overall object here? I mean, I get it because it's part of this object and not part of the body, so I see it, but it's still oddly confusing, at least for the moment. I'll read the documentation later and learn about this. What do we got? Create a new rotated badge symbol view to encapsulate the concept of a rotated symbol. Adjust the angle in the preview to test the effect of the rotation. Oh, okay, that's cool. So I can just flip it upside down if I want to. New file from template, SwiftUI. And we're going to be calling it the rotated badge symbol. We can remove this. There we go. We can remove this part because we won't be showing any of this. Again, global declarations. Good. We can call in the badge symbol. No initializer because it's not needed. -60, and the rotation effect as anchor. We're anchoring this to the bottom. And though, since we are actually declaring an angle there above, we need to initialize it. Probably this is the reason why we're using static and we're not really using anything that is non-static, because you would have to initialize it. But can't I just give it a default value and not have to initialize it afterwards? Degrees 5 according to this. Oh, that was horrible. There we go. So in theory now I'm initializing all the values. Like, what happens if I just initialize it at the top? I wouldn't have to declare it there in the for the preview. Let's just wait for this to load in the meantime. And move on to the next section, which is the... oh god. So, section 4. Combine the badge, foreground and background. Ah, cute! Okay. Wait, -60 means that he's going overboard. Like, okay, hold on. I'm gonna make it like a 180 degree. It should just like... wait, 180 doesn't really make much sense though. It should look the same. So I'm not turning... oh, wait, no. 180 is like... if it's vertical, I'm assuming, since it looks like it's 5 degrees. So 180 should be upside down, in theory. Did I overdo it? It's an angle. How big is this? And this is not... I want to make this actually smaller, not bigger. Also, what degrees am I working with here? It's degrees, it's not radians, it's not anything else. So, what did my... 9? Okay. No, I want this to be the smallest it can be. Let's make it 75. So I want this to be the smallest, but it's anchored to the bottom. It's taking... the rotation is the angle, so that's fine. 10? I am not understanding this rotation. 25. What? Rotating it at an angle. It's anchored to the bottom. Is it saying that it's not rotating it there on the spot? It's rotating it... okay. What if I anchor it somewhere else, like a not at the bottom? What else? What other choices do I have? Bottom, leading, bottom train, center. Anchor it to the center. I want to see if it's the center of the screen or if it's the... it looks like it's the center of the screen in this case. So what happens if I make it a 45-degree angle? It should look like this from the center of the screen, though. Of the screen. Can I not center it based on itself? So this is based on the top, based on the origin of a view. The origin of a view. Is it the center of the screen again? Like, what part of this? Not what I'm expecting. What is this? Interesting. So what else have I got? Can I just not have an anchor? If I don't, it doesn't... Okay. What other choices do we have? Bottom leading, bottom trailing, center leading. A point that's centered vertically on the leading edge of a view. Like, everything is set for the view. I don't... Why not based on my items X and Y area? Okay, now I'm curious. What happens if I anchor to the top? How does it actually look? So it just dangles? Like, what is this? Top of what? Top of the view? How is this even working? Alright, fine. It's not a big deal. There's so much for me to experiment with. Now, let's go with combining the badge foreground and background. The badge design calls for the mountain shape to be rotated and repeated multiple times on top of a badge. There we go. Thank you. So it's going to be from the center in this case. Define a new type of rotation and leverage the for each view to apply the same adjustment to multiple copies of the mountain shape. Create a new SwiftUI called badge. Okay. Now we're going to have the experiment with what I'm trying to say here. I mean, the idea would be that you can create a view for this and just like centralize it in one view and then store it into a sub view later down the line, so you already have a pre-created generic overview with the centering already applied to it, and then you just take that centering and the rules that you apply to that generic view over to a more complexified structure, like a more grouped structure. That makes more sense. So that seems like the normal way to go, I guess. Place the badge background in the body of the badge. Yeah, okay. Badge background. There we go. What else then? So, we got the badge background and that's fine. Within the body. Lay the badge's symbol over the badge background by placing it in a Z stack. Alright, we're doing this. So we're placing the badge symbols. Oh lord, hold on. Because I can understand that I did the rotate the badge symbol. I messed this up a little too much at this point. So I'm just gonna put the values back as they were. So at least the tutorial doesn't show something completely broken that doesn't make any sense. Bottom with a 5 value here. Oh, go. Oh, go. There we go. Okay, now this is good. This we're happy with. Let's go back to the badge. So in this case, I need to put this into a Z stack. Again, the lazy way would have been for me to just like do it like this. Embed in a Z stack. I love that you can also embed in a list. That is so smart. And we need to lay the badge symbol over the badge background by placing it in a Z stack. Fine. Then I need to declare the badge symbols outside of the body. Var badge symbols. Too much. Some view. Rotated badge symbol, taking as parameter an angle, which is an angle with 0 degrees. So no change, and an opacity of 0.05. That's nice that you can add an opacity to it. It's almost like you don't need to worry about alphas and other coloring details when you're building this kind of shapes. You can already apply it there directly. And badge symbols. There we go. So by adding this, what am I supposed to be looking at? A mountain on top of a yes. Okay. Correct the size of the badge symbol by reading the surrounding geometry and scaling the symbol. Ah, yes, my favorite. Let's go. So now we're going to be using my favorite thingy. The geometry reader. Geometry in. And we can just scale these badge symbols based on the size of the geometry. That's nice. Scale effect. Yes. And we're going to be using 1.0 divided by 4.0, comma, anchor to the top. Interesting approach, but okay. 1/4 with an anchoring at the top. Okay. And we're going to place it, so we're making it smaller to begin with, and we're applying geometry dot size dot width divided by 2.0. Okay, so it's the same as making a half, fair enough, with a y value of how much? 3/4 the height. Okay, 3/4 of the height. Okay, 4.0. So okay, fair enough. Times geometry dot size dot height. So this is okay. Let's just make this a little more readable, because we got the first value x and y with its closing no, I'm gonna leave this as is, because otherwise it's gonna be unreadable. This much I'm fine with. Value number 1, and this is value number 2. There we go. So the modifiers are at least clear to read. And we made this a lot smaller, but we made it only 1. Then what? Add a for each view to rotate the display of the badge symbol. A full rotation, 360 degrees rotation, split into 8 segments. Create a sun-like pattern. Yeah. By repeating the mountain symbol. Oh, that's cool. That's cute. So I got the badge symbol here, and that's fine. So we're going to create a rotated badge 8 times for each. That's what we're working with for now. So 0 to less than 8. So yeah, makes sense. It's 7. Since we start with 0. Index in. The rotated badge in this case. There we go. And we're applying the degrees. So angle is no longer an angle, it's pure degrees in this case. Degrees with not this value, since... Wait a second, color me confused. Why is this like this? Why can't I leave this angle and declare the degrees in here. Okay, you know what? We're gonna follow the tutorials and not just... We're gonna play with the logic later on. Degrees with how many parameters in this case? 1. Just the calculation of the degrees itself. Okay, fair enough. Index and divided by 8 with times 360. We're leaving the opacity, but we're leaving the opacity for when? For H. What? I don't really understand why you wouldn't apply it to all of them, but sure. Sure, okay. And then we have a scaled... Oh, there we go. We have a scaled to fit parameter that we put in at the end of the Z stack. Dot scaled to fit. That means what? That means that it's going to squeeze? I mean, it doesn't look like it's squeezing, so I really don't know what that... Ah, there we go. Oh, pretty. That looks nice. That looks very, very nice. Okay, so it squeezes everything so that it just comes together. To keep the project organized before moving on to the next tutorial, collect all the new files into a badges group. Okay, so we got badge, 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 and badge. Content view is the only one that is not part of anything. Okay, easy. New. Actually, no, I can just right click and do this. New folder from selection, yes. And we're calling this badge. Badges. Very nice. Very good. Very good, we like this. Perfect. And with this, we have finished this drawing chapter, and it completely broke. Oh, it's processing the files. So the next part will be animating views and transitions. When using SwiftUI, you can individually animate changes to views or to a view state, no matter where the views are. SwiftUI handles all the complexity of these combined, overlapping, and interruptible animations for you. Ooh, smooth. Okay. That's nice. I love how it says that this should take like 20 minutes. The problem is that I've been streaming for an hour and 18 minutes just to get the geometry here running. I did play with a lot with that stuff, so yeah, that was a bit of a time waster. But it's okay. That was just as fun as it needed to be. So that's good. We like that. Either way, I'm gonna end the stream now for this morning, because that's enough geometry, literally everything for this for this part of the tutorial, and we're gonna be moving on to the animations with the next stream. So thank you all for watching, and thank you all for following. I'll see you guys later tonight for some gaming.